Hello and welcome back to the lab. Today on the bench, we're continuing on with the 485 restoration. In this video, we're going to take a look at the horizontal section on the scope. In the last video, we took a look at the power supply and the tube for the geometry alignments. In this video, the horizontal section and time base. The next video will be the vertical section. There will also be a playlist for those that haven't seen the first two videos on this. There'll be a playlist on the channel that has the complete restoration of this. You just need to go through the video start to finish. And with that, let's get into it. Okay, on this one, my horizontal gain looks actually very good. The part of the waveform in question that I am looking at is right here at the tips, and you need exact alignment on 1 and 9. So 0 and 10, there's some non-linearity in the tube. So 1 and 9 have to be perfect, and these look really good. So on this one, the horizontal gain doesn't actually need much. Now you can also see what I was talking about as you don't see the trace as it shoots up because it's moving very quickly, but then it has this kind of fall off on this curve where it comes down. I can exaggerate that by blowing this up. So it doesn't fall linearly. So you don't see the time mark. It's there, but it's just faster than the scope can capture. You don't want to work on this side of the curve. You have to kind of connect the dots and work on this side of the curve where you actually have the step. Okay, now we got to check ACAL. Let's see here. Get this set back up. Still 0.1 milliseconds time marks, which is fine. I'm going to bump the intensity down just a touch. Same thing, looking at the tips of the time marks, and I'm happy with that. All right, so A-sweep is in good shape as well. Don't know what they mean by time on, but they want 1 millisecond time markers. Yeah, variable timing is good. So they want 1 millisecond time markers, 0.1 milliseconds on the time base, and they want to make sure there's less than 4 divisions with the variable time completely counterclockwise. So my variable time division is working perfect. Okay, so we need to check the B register. So we're back to 0.1 millisecond time marks, 0.1 on A and B time base, alternating on the time bases, and both are triggering normally. Delay time position is 0. Now, mine is actually in perfect alignment, but I had a question about this specifically where the time bases aren't lined up, and so I'll detune it, and then I'll show you guys how to tune it. But if you see, we have 2 sets of waveforms. So both of them match up exactly, so we have coincident waveforms. So if R1325 is out, which R1325 is right here on the B register. Just to prove we have both time bases on there, I'll detune the B register real quick. Flip. And now, with delay time position at absolute 0, they're not coincident anymore. If I drop this back down, the A and B registers are off. So what you need to do is, all you have to do is set the waveforms to be exactly the same. There we go. Also, while we're doing this test, if I rotate the horizontal knob to its extreme, The waveform should cross the center line in both directions. My horizontal centering is fine. And A sweep length check is making sure A sweep starts. We have 10 divisions of sweep, but you should have less than 11.5 divisions of sweep, and it helps if I get my hand out of the way. So with this being A sweep, now totally A sweep, if I turn this, so we should have 10 time marks, which we do. We should not have 11 time marks, which we don't. Okay, I'm ready to do the delay start stop. The delay start stop pots are on this side of the scope. I'll show you exactly where here in a second, but what's wrong is if I move the delay time, we can see the intensified trace is moving, so the intensified trace needs to be on the number 2 time mark, which it is, but it's lagging just a touch, so just a little bit. So I do need to adjust delay start and probably delay stop, but let me show you where those adjustments are. The delay start and stop adjustments are right here. These two potentiometers, they're not labeled with an R number, they're actually labeled delay start and stop. So those are what we will be adjusting. So what I want to adjust is I need to bring the delay a little bit closer. It should just hit the rise on the time mark. Right there, looks good. So now we have to do the exact same thing, but we have to roll this all the way up to 9. Right there. And it wants you to bounce back and forth on the 2 real quick because it does interact. So I'm going to do that a couple more times and iterate through, because I just checked the 1 and the 1's a little too far forward now. So okay, just took twice more through and it's looking very good. I need to check the 0.1 millisecond delay linearity, so I need to adjust the time mark steps to 50 mic. Fully counterclockwise, and the first marker should be displayed. It is. Now we need .95 on the delay time position. Marker should be towards the center. It is. All right, so we need to adjust the position control to put this dead center on the screen. And then 8.95. There's 8.9. All right, there is 8.95, and we are exactly where we should be. So the 0.1 millisecond linearity is fine. A time to 0.1. B time to 10 nanoseconds. Horizontal display to Alt. And 0.1. Okay, so we're checking 0.1 microsecond timing on A and B. So we're going to move this over to a reference point, which is right there. So I referenced off of the B trace. All right, now we need to go to 9. And timing is good for the 0.1 microsecond A and B timing. B to 0.1. And 0. That's going to need a line up. C1248 needs adjustment. C1248 is right here. So this is the capacitor that I'll be adjusting. And what I'm looking at for the adjustment is an overlap of the traces. So they should be at 0, 0, they should be identical. Let's see what we can do. Okay, you have to fiddle with the delay time position and the capacitor to line up the front of the traces, and then they'll line up correctly. Because if I detune this just a little bit, you can see they are lining up perfectly. So the timing's right. The absolute horizontal position doesn't matter in this one. The timing is what's important. So this is now set correctly. Okay, setting up for the 1 microsecond timing. So we want 1 and 5 to 0.1. 1 microsecond time marks. A. All right, we're doing the same thing just with different timing. So reference point's going to be here Not concerned with what's going on down here, just with what's right here at the moment. Now we're headed to 8, 9, 5 exactly. And we are fine, actually. So C1242 does not need adjustment on this one. If this was off, that's when you'd adjust that capacitor. But this one is in good shape. Okay, setting up for the sweep linearity. 20 nanoseconds of division. We need to adjust the trigger hold off to max, but not click it to BNZ. So long trigger hold off, but not BNZ. So this is the linear ramp for the sweep that they're talking about. I'm supposed to have a step, one ring, and then a ramp. So I'm going to see if I can tune out a little bit of this ringing that's right here. This is kind of what concerns me. For this test setup, I didn't use the external trigger because I didn't need it. It's just triggering off of the step, and I'm doing some averaging to clean up the waveform. So let's see what we can do with this. That would be bad, so that's too far. That's ringing. So what we want to do is that looks the cleanest right there. So we also need to look at 10 nanoseconds. So we're going to kick it down. Oh, that doesn't look good. And then back to 10. That looks like the best compromise between the two. Okay, for this one I'm doing it the Tektronix way. And I'm needing to use the 184 for this, so I'm off the rubidium for just this one real quick, but we're also going to check it with my RF signal generator, which is on the rubidium. So the way this works is we're on step 29, adjusting the 5 nanosecond timing. I have 50 nanoseconds coming in for the trigger, 5 nanoseconds at the input, displaying it, so they're time correlated because they're coming from the same device. You wouldn't be able to do this from, say, two TG501s, even if they were locked to a reference because these two signals aren't time correlated. Because they're coming from the same device and they're generated from the same local oscillator, these two are time correlated, so this works. But what we're looking for is first and ninth with time marks. So my 5 nanosecond timing is actually very good. We can move on. Now for 2 nanosecond timing, C1364 and R1226 are off. We can tell because if I reference this peak here, this peak's off. So this does need some adjustment. It's not terrible, but it's off enough where we can do better. See if I can find these real quick. Well, that was a scavenger hunt. Here is the capacitor that you need to trim. And here so here's the cap. Here's the resistor. So between the two of those, we need to make the waveform line up. So let's see if we can do that. I need a different terminator. My 50 ohm terminator is starting to die. May have to order a couple more of those here soon. Just double check that resistor real quick. Okay, checking the 1 nanosecond time base. I have a 500 megahertz signal going in at 1 volt peak to peak. I'm not using the time mark generator because I get a cleaner signal out of my RF frequency generator, and this is backed up by the rubidium, so I have the stability I need. I am looking for 1 peak every 2 divisions, which I am getting. I can't do this straight to a gigahertz for the 1 nanosecond per division sweep rate due to the fact that that's too fast for the front end, and I don't get enough signal and the scope won't trigger. So have to do it at 500 megahertz. But our 1 nanosecond time base looks good. Manual wants to check 1, 2, and 5 nanosecond sweep linearity. So we are at 1 nanosecond. Here's 2. That looks very good. And then I'm referencing the top of the waveform. That's a 500 megahertz right at 2 nanoseconds. For 5 nanoseconds, that would be a 200 megahertz waveform. We'll bring this down just a bit, kick this back 1. And that looks real good. So our fastest time bases are working normally. Okay, the rest of the time base document, or the rest of the calibration document, is just checking the time bases out, just checking the accuracy over all the ranges and the delay time accuracy and things like that. So I will run through that real quick, but in an effort to keep the video from getting too long, I will just cut that out because there's no more adjustments. This is all just making sure everything looks right. Starting at step 40, we are into the vertical section. Thanks for stopping by the lab and taking a look at the horizontal section of this 485. As always, I will see everybody in the comments and the next video. Bye for now.